Hi everybody, welcome to my YouTube channel. So hope I can help you to understand all the concepts and wish you enjoy my videos. So gonna use these two books, which is for the UKA level, but don't need to worry about it too much even you study with the different exam boards, including like CIE, AQA, or last qualification. Because yeah, most of the contents are similar. And yeah, if you have any questions, you can just leave the comments below or send me the private message via my Instagram. Yeah, so you can find my Instagram account on the channel's description. And let's cover the first one. So the first one we need to cover is about the index lows. So yeah, to define lows is kind of rules, right? And this is the four basic lows that we always need to remind to solve the questions. So the first one is a to the power of m times a to the power of n equals a to the power of m plus n, right? And yeah, let's see some points. So we can check that they have same base, right? So in this case, we can try to make some examples. Just easy example. So yeah, I just set a equal like 2, and 2, let's say 2 square times 2 cube. And you know that this 2 square, which means we multiply 2 twice, right? And 2 cube just means we multiply 2 3 times. And yeah, which means we are multiplying 2 1 2 3 4 5 times. So we can just write down as 2 to the power 5, and this 5 on the power, which is from 2 plus 3, right? So you can just easily think about this simple examples. So yeah, and the second one, which is a to the power of m divided by a to the power of n equals a to the power of m minus n. So we can also make the simple examples. So let's set a equals 3. So let's say 3 to the power of 4 divided by 3 to the power of 6. And we know that this just means we multiply 3 4 times, and this just means we're just multiplying 3 6 times. 3 4 5 6. So which means and about this one should go to the denominator side, right? So you can just simplify as 3 times 3 times 3 times 3 over 3 times 3 times 3 3 and 3. And we can check that we can eliminate some numbers, right? Because for the numerator side we have 4 3's, right? But for the denominator side we have 6 3's. So we can simplify as 3 3 3 3 3 3 3 3. So you can simplify as 1 over 3 square, right? Which means this 2 comes from m minus n, which is 4 minus 6, right? So yeah, and let's move on to the next one, which is a to the power of m to the power of n. And let's also make some basic examples. So let's try with 4. So 4 square to the power of 4. Okay, and this means we multiply 4 twice. So 4 times 4 to the power of 4, right? So which means you know that 4 times 4 equals 16. So it's just basically multiplying 16 4 times, right? And if we change 16th to 4. So we can use it at 4 square times 4 square times 4 square times 4 square, and then we can just simply use the first law to simplify this one, right? So we can write down as 4 to the power of 2 plus 2 plus 2 plus 2, which is 8, right? And this 8 comes from 2 times 4, which is m times n. So we can also use this one. And the last one, a times b to the power of n equals a to the power of n times b to the power of n. And we can also prove with this one. Let's say a equals 2, b equals 3, and n equals 5. And yeah, know that this means 2 times 3 equals 6, right? So 6 to the power of 5. So we can write down as this, but to make this form, we cannot use this one. So which means you're just expanding this 5 to each numbers. So we can write down as 2 to the power of 5 times 3 to the power of 5. Yeah. So this is just simple. So yeah, so this was about the index laws, and we're gonna try one question from the exercise 1a, question 3a. So the question is about simplify 6x to the power 4 plus 10x to the power 6 over 2x. Okay, so in this case, for the denominator, there's just one expression, right? So we can think about dividing into 2 expressions. So we can write down as 6x to the power 4 over 2x and plus, because we just need to follow this sign, and 10x to the power 6 over 2x. And we can also simplify, right? So 6 and 2, they have same factor 2, right? So we can just divide by 2, which means we can get 3. And we can just use x to the power 4 and x to simplify this one. We can just use this second law, right? So which means we can write down as 3x to the cube, right? And we always need to remind that it has 1 for the power, right? So it is 3x cubed plus we can also divide 10 and 2. I mean, we can simplify 10 and 2. So we can write down as 5 and x to the power 5, which is 6 minus 1. And yeah, for this one, 4 minus 1. So we can simplify to 3x cubed plus 5x to the 5. Okay. And next one, expanding the brackets, which is 1.2. And yeah, expand. And sometimes we need to simplify, but this is just about for the when you prepare for the exam. But yeah, anyway, so the first example, how to expand ax plus c times a square x minus by minus d square. So yeah, so we always need to remind that we need to multiply with all the terms like this. So which means they have 2 terms and it has 3 terms, right? So which means the answer should be with 6 terms. So yeah, let me just write down the order. So we need to multiply with all the terms. So this and this and this. So let's try with the first one, ax times a square x. So ax times a square x, and for the next one, plus an ax times minus by. So ax times minus by, and next one, ax times minus d square. And next one, we can use this one, right? is we just multiply with ax with this 3 times. So need to expand with this one. So c times a square x. So c times a square x, and plus also c times minus by plus c times minus d square, which is the last one. And then we can just calculate and simplify. So for this one, which is ax times ax square x, so you can write down as a cube x square, right? And for the next one, ax times minus by, so we have 2 different numbers, which is a and b, so you can just write down as minus ab xy, right? So let's just change this with this on. So minus ab xy, and the third one, which is ax times minus d square, so you can just write down as minus ad square x. And let's move on to the next one, which is c times a square x, so you can write down as ca square x. And next one, c times minus by, so you can write down as bcy. And the last one, which is c times minus d square, so you can say it's cd square. Yeah, and so this is we just expanded this one, but we can simplify using the bracket, right? So, but yeah, if it is needed, we can make a bracket with x with these 2 terms, right? So we can write down as a cube x square and make a bracket with x, and we can put this one ad square minus ad square and ca square, and yeah, just rest of them, abxy minus bcy minus cd square. Okay, and let's try the question. So this question's on exercise 1b4, and the cuboid has its length is x plus 2, 2x minus 1, and 2x plus 3. And need to prove that the volume of this cuboid equals 4x cubed plus 12x squared plus 5x minus 6. So yeah, the cuboid, which looks like something like this, right? Yeah, I'm not that good at drawing, so yeah, anyway. So you can say it's just x plus 2, 2x minus 1, and 2x plus 3. And you know that it should remind about the volume formula, right? So 3 equals, yeah, just this times c, this. So base area times height, right? So need to remind all the small formulas as well. And yeah, let's try to prove this one. Yeah, so you know how to get the volume, so you can just multiply all the lengths, right? So 3 equals x plus 2 times 2x minus 1 times 2x plus 3. So to make this form, we should expand all the terms, right? So let's try to expand the first 2 terms. So x plus 2 times 2x plus minus 1, so x times 2x, which is 2x squared. Next one, x times minus 1, negative 1, which is minus x. And 2 times 2x, which is 4x. 2 times negative 1, which is minus 2. And then you also need to expand with this term, right? So we should expand it again, but we can see that we can simplify this term, right? So we can change x coefficients to 3. So let's simplify to 3x. Okay, then yeah, so expanded 2x squared times 2x, which is 4x cubed. 2x squared plus 3, which is 6x squared. And 3x times 2x, which is 6x squared. And 3x times 3, which is 9x. And minus 2 times 2x, which is minus 4x. And last one, minus 2 times 3, which is minus 6. And we can also simplify. So we can simplify this one, x squared, right? So 4x cubed, nothing to simplify, and we can simplify to 12x squared. And for this one, we can simplify to 5x, and last one, minus 6. So yeah, finally we can prove that the volume of this cuboid equals 4x cubed plus 12x squared plus 5x minus 6. Okay, let's move on to the next one. So 1.3 about factorizing. So it is simply opposite of expanding. So these are some key formulas to know. I mean, you don't need to memorize, but it's useful, right? So the first one, x squared minus y squared equals x plus y times x minus y. So this is you can find this one by expanding these two terms, right? So factorizing is just opposite. So if we look at this one, and we should know how to make this. So this is just simple meaning of factorizing. So yeah, the first one, this formula, and the second one, x cubed plus y cubed equals x plus y times x squared minus xy plus y squared. The third one, x cubed minus y cubed equals x minus y times x squared plus xy plus y squared. Yeah, and the difference between these two formulas, you can just easily find that this one is x cubed plus y cubed, right? So we just write down the same sign for the first one, which is x plus y, but we use the opposite one for this one. And yeah, it also applies to this formula. So it is minus, right? X cubed minus y cubed. So we take minus and we take plus for this one. And the last one, x to the power 4 plus x squared y squared plus y to the power 4. So this one as well. So this one, x squared y squared x squared y squared, same, right? But we just take opposite sign for x times y on the middle, right? So yeah, this is some key formulas, and yeah, it is useful. So anyway, so yeah, this one is a kind of simple example, right? So 6x squared minus 11x minus 10. So factorize. So yeah, let's try this one. So we can just make some position like this to make it easy. So let's say, because this one is x squared and the middle part is this x, right? So we can just think that it should take x and x, right? And we know that if we multiply these two, then we should get 6x squared. So it should be, yeah, we can make some combinations like 6, 1, 2, 3, 3, 2, 1, 6, something, right? And we also need to think about this term. So this one minus 10, so it can be 10, 1, 2, 5, 5, 2, 1, 10, right? So gonna, yeah, factorize this one. So let's try with 3x and 2x. And we know that this part is minus, right? That has negative sign, which means one time should be negative, right? Should take negative. So it's 3x, and we know that to get minus 11x should cross multiply, right? Do the cross multiply. So 3x and times this one, which is just constant number. Let's take 2, and should be 5, right? So this one, 3x times 2, which is 6, 2x times 5, which is 10, but it doesn't make sense, right? So let's try with different combinations. So what about 5 and 2, like this. So cross multiply to make minus 11x, so 3x times 5, which is 15, right? And 2 times 2x, which is 4. And if you take a negative sign for this one, then you can basically make minus 11x, right? So 3x times minus 5, which is minus 15x, and 2x times 2, which is 4x. Then we can make minus 11x. So, and we can just take brackets like this, and we can write out the answer as 3x plus 2 times 2x minus 5. So I hope you remember how to factorize, because this one is just GCSE's level, right? Okay, and next example, so x cubed minus 25x. Right, so this one doesn't look like this, so you can think like it's hard to factorize, but if we cannot factorize like this, we're just thinking about the same factor, mutual factor. So this one x cubed, and this one this one is minus 25x. So you can just think about what about making a bracket with x, right? Because they both have both two terms have x as a factor, right? So you can make a bracket with x, and inside the bracket should be x squared and minus 25, right? And if we try to factorize, because we can factorize this one, right? And this one, you can just use the first formula, which is x squared minus y squared. So if we factorize, then it's x times x plus 5 times x minus 5. Okay. Right, and let's try this example, this question. So this one from exercise 1C4 question 4. This question is about factorize x to the power 4 minus y to the power 4. So you need to factorize, and also for this one you can just use this first formula, right? So so x to the power 4 minus y to the power 4, so we can factorize to x squared plus y squared times x squared minus y squared. And we know that we cannot factorize this one anymore, right? But we can factorize and simplify this one. So times x plus y times x minus y. So this one should be the answer, right? Okay, and let's move on to the next one. Negative and fractional index. So this one as well, this is kind of rules, right? So 4 key rules need to mind to solve the questions. So the first one, a to the power of 1 over m equals m square root of m root a, right? So also, for example, before this one, you always need to remind that square root of a equals a to the power of 1 over 2. Okay. So which means that because this one is square root, right? So this one includes 2 on this side, right? And what about cube roots? We can just write down as a to the power of 1 over 3, right? So this is the same method. So if this one is m, then we can just write down as a to the power of 1 over m. Okay? And the second one, so you can also use the same example. So what if we say is square root of a cubed? We should write down as a cubed to the power of 1 over 2, right? And we can use the index law, which is this one, right? A to the power of m to the power of n, which is a to the power of m times n, right? So if you use this one, then we can also write down to a to the power of 3 over 2. So this one also makes sense, right? And also the next one, a to the power of minus m equals a over a to the power of m. So if you see the negative sign on the power, it just means we're just changing the position of denominator and numerator, right? So yeah, example. So what if it's a to the power of minus 3? Then we can write down this one to a cubed to the power of minus 1, right? Which means if we use this rule, then we can change this one to 1 over a cubed, and this one also makes sense. And the last one, if the power equals 0, it's always 1, right? Because this one is just kind of basic rule. Okay, and let's try this example. So 2x to the power of 1.5 divided by 4x to the power of minus 0.25. Okay, and you can see that there is some decimals, right? So yeah, what if we change to the fractions? So 1.5 we can change to 3 over 2, and minus 0.25 we can change to minus 1 over 4. And yeah, then let's try to simplify. So it's 2x to the power of 3 over 2 divided by 4x to the power of minus 1 over 4. And know that we can change, we can move this one to the denominator side, right? So it's 2x to the power of 3 over 2 over 4x to the power of minus 1 over 4. And we can simplify the numbers. So it should be 1 over 2, right? So 2 on the denominator side, and just 1. And we can also simplify this variable, right, x. And we can also use the index law that we covered on the first part, right? So we can simplify as x to the power of 3 over 2, because it's divide, right? So we can say it's minus and minus 1 over 4, and we can finally change to 1 over 2 times x to the power of 3 over 2 plus 1 over 4. And if you simplify this one, then you can get 1 over 2 x to the power of 6 plus 1 over 4, which is 1 over 2 x to the power of 7 over 4. So yeah, this one should be the answer. Yeah, so this just you always need to combine all the formulas, some key rules to solve the questions, right? Okay, and yeah, let's move on to the question. So this one, page 11, example 11. So y equals 1 over 16x squared, and need to find y to the power of 1 over 2 and 4 times y to the power of minus 1. So let's try this one first. So y equals 1 over 16x squared, and need to find y to the power of 1 over 2, which is square root of y. Yeah. So if we substitute y to 1 over 16x squared, then we can change to square root of 1 over 16x squared, and know that so we can we can simplify it inside the square root, right? So Yeah, so 1 over 16 equals 1 over 4 square, and x square, which is just x square. So you can simplify to 1 over 4 times x, right? So this one should be the answer for the first question, and the second one, which is 4 times y to the power minus 1. Yeah. So let's try to find y to the power minus 1. So y to the power minus 1, which is inverse, right? Sorry. We're just changing the position between numerator and denominator. So yeah, y equals, we can write down as x squared over 16, and y to the power minus 1, which is simply 16 over x squared. And yeah, next part, which is just multiplying 4 on the both sides, right, to get this one. So you can simplify 4y to the power minus 1 equals 4 times 16 over x squared, which is 64 over x squared. So yeah, this is also a quite simple question. Yeah, and this is question for from exercise 1D5. Yeah, try to solve this question. Okay, and alright. So the first one, y equals 1 over 8 x cubed. Find the first one, which is y to the power 1 over 3. Second one, 1 over 2 times y to the power minus 2. So yeah, the first one is, yeah, no, that is the same question, right? So yeah, first one, yeah, let's change y to, it's 1 over 8 x cubed, right? And need to find y to the power 1 over 3, so we can just take 1/3 like this, and we can, we know that 1 over 8 equals 1 over 2 cubed, right? And x cubed is just x cubed, 1 over 3, so we can simplify to 1 over 2 x, right? Okay, this is quite a simple question. And the second one, 1 over 2 times y to the power minus 2. And yeah, first thing to do, let's find this one, y to the power minus 2. So y equals 1 over 8 x cubed, and need to find the power minus 2. So let's take this one. Yep. And know that this minus 2, sorry, this negative sign means need to change the position between the numerator and denominator, right? So we can change as, yep, 8 over x cubed or squared, right? And if we expand the square, then we can get 64 over x to the power 6. And also need to multiply 1 over 2 to get this one, right? So times 1 over 2, which is 32 over x to the power 6. Okay. Right. And yeah, and next concept, surds. This is also simple, so yeah, let's look at these two rules, simple rules, which is square root of a times b equals square root of a times square root of b, which means we can, yeah, just check with a simple example. Square root of 2 times square root of 3 equals square root of 6, right? Which is yeah, simple. This one as well, square root of a over b equals square root of a over square root of b. So yeah, what if we say square root of 2 over 7, which means we can just write down as square root of 2 over square root of 7. So this is a bit simple, and let's move on to the example. So the first one, which is 5 square root of 6 minus 2 square root of 24 plus square root of 2, 94. Okay, so to simplify, because we know that this 6 we cannot simplify anymore, right? But 24 or 294 we can try to simplify. So let's try to simplify this 24 first. So know that this 24 has factor for yeah, we can just find the factors, right? So it's basically 6 times 4. Know that 6 is 3 times 2 and 4 is 2 times 2, so we can simplify to 2 cubed times 3, which means we can simplify square root of 24 to 2 square root of 6, right? So if you multiply this 2 and this minus 2, then you can get minus 4 and square root of 6. And also for 294, let's try to find the factors. So 294 factor, we can divide by 2. 1 4 7, we can divide by 7, so 2 1 7 3. So we can say 294 equals 7 squared to 3. 7 squared times 2 times 3. So we can simplify square root of 294 to 7 square root of 6. So 7 square root of 6. And inside the square root, which is all the same numbers, right? So we can just simplify to 5 minus 4 plus 7 times square root of 6. So which is 8 square root of 6. Right, yeah. Looks tough, but yeah, just use just simplify, right? And next one, 2 minus square root of 3 times 5 plus square root of 3. So yeah, this is just simple expansion, right? So the first one, 2 times 5, which is 10, and 2 times square root of 3, which is 2 square root of 3. And minus square root of 3 times 5, which is minus 5 square root of 3. And minus 3 times minus 3, which is square root of minus 3, which is minus 3. So we can simplify to 7 minus 3 square root of 3. Right, so that's also just a simple question. And question 5 is from exercise 1E, third question. Let's simplify square root of 75 minus square root of 12. So this one is also a bit simple, right? So to simplify square root of 75, need to find the factors of 75. So 75, so we can say is 15 times 5. Sorry, so 17 times 5. Oh, sorry. Yeah, so it's divided by 5, so 1 5 and 5 3. So we can say square root of 75 equals square root of 5 squared times 3. So we can simplify to 5 square root of 3. So 5 square root of 3 minus 12. So we also need to find out the factors of 12. So it's just basically 4 times 3, which is 2 squared times 3. So square root of 12, you can say it's 2 square root of 3. 2 square root of 3, and it's a simple math, right? So 3 square root of 3 must be the answer. Okay. So yeah, it's almost done. So let's move on to the next concept. So yeah, 1.6, rationalizing denominators. So yeah, rationalizing, which just means make denominators to rational number. So the key point to remind is need to understand this formula. So x plus y times x minus y equals x squared minus y squared, which means yeah, if we just expand x plus y squared, then we can get x squared plus 2xy plus y squared. And if we assume that x and y are surds, which means this 2xy may not eliminate, right? So we need to use this formula. Right, so let's move on to the example. Yeah, sorry. So the method, yeah, so how to rationalize, which is just, yeah, multiplying another pair of the terms, okay? So which means this one is square root of 5 plus square root of 2 over square root of 4 minus square root of 2. And need to, so yeah, let's just assume that this one is x minus 5. Then we should multiply on numerator and also the denominator to make denominator to a rational number. So need to multiply square root of 5 plus square root of 2 on both numerator and the denominator. Okay, so yeah, let's just simplify. So yeah, if you know this formula, then you can just calculate directly, right? So it's just square root of 5 times square root of 5, which is 5, and because it's minus square root of 2 times square root of 2, which is 2 minus 2. So you can get the denominator, and for the numerator, it's just simply, yeah, square root of 5 plus square root of 2 squared, right? So you can simplify to 5 plus 2 plus square root of 2 square root of 10. And to simplify, 7 plus 2 square root of 10 over 3. So this one should be the answer, right? Okay. And yeah, move on to the question. So exercise 1F4. So is 3 minus 2 square root of 5 over square root of 5 minus 1. And need to change to this form. Okay, so need to make the denominator to rational number, right? So always need to remind x squared minus y squared equals x plus y times x minus y. So to make this one rational number, then we should multiply square root of 5 plus 1 on the numerator and also the denominator, right? So yeah, let's just simplify. So for the numerator is 3 minus 2 square root of 5 times square root of 5 plus 1. So we can say it's 5 square root of 5 plus 3 and minus 10 and minus 2 square root of 5. That's it? Yeah. And for the denominator, it's just simply 5 minus 1. And to simplify, we simplify these two terms, which is just square root of 5. So square root of 5 and this number's 3 minus 10, which is minus 7. And denominator, which is 4. So you can say it's minus 7 over 4 plus square root of 5 over 4. So which means P equals minus 7 over 4 and Q equals 1 over 4, right? Okay. Yeah, next one. Yeah, yeah, so it's done for the chapter 1, and let's just try some questions. So this one is from mixed exercise. All the questions below are from mixed exercise. So question 19, which is 27 to the power of 2x plus 1 into 3 to the power of y, and y in terms of x. Okay, so let's try this one. So we know that yeah, so we should realize that we should know that that we can make 27 into 3, right? So 27, which is 3 cubed. So we can just substitute 27 to 3 cubed. So 3 cubed, let's say it's 3 cubed to the power of 2x plus 1, right? And by the index law, we can expand this one, expand the powers to 6x plus 3. And yeah, need to change to this form, and because we have the same base, which is 3, right? So you can just say y equals 6x plus 3, because they have same base. Yeah, so it's quite a simple question. And question 21, it's about rectangle, length equals 1 plus square root of 3 and area equals square root of 12 cubic centimeters, and find its width in this form. Okay, so rectangle, just simple, yeah. And know that just one length, which is 1 plus square root of 3, and need to find this one, right? So we know the area that equals square root of 12, and then we can make equation, right? So rectangle area formula, which is just yeah, a times b, which is 1 plus square root of 3 times something, yeah. Let's say it's x, okay. I know the area, so we can just change a to square root of 12, right? Okay, so to make right hand side x, we can just divide by 1 plus square root of 3, right? So x equals square root of 12 over 1 plus square root of 3. And to get x, we should rationalize this at the left hand side. So yep, so we know that need to multiply 1 minus square root of 3 on numerator and also the denominator. So yep, and then it's just simple. So numerator, which is square root of 12 minus square root of 36, because it's 12 times 3, right? Sorry. And denominator, which is just 1 minus 3. And yeah, and then we can simplify, so that square root of 12, which is 2 square root of 3, and 36, which is just because 36 equals 6 squared, so we can say it's just minus 6. And denominator is just minus 2, so we can simplify to 3 minus square root of 3, and this one should be the answer. So a equals 3 and b equals minus 1. Right, so next one, I think this one is the last one. Yeah, so 24 is 4x cubed plus x to the power 5 over 2 over square root of x, and need to change into this form. Okay, so the first thing to remind is that the square root of x we can change to x to the power 4 over 2. So we can yeah, change square root of x into this one. So let's just change it. 5 over 2 over x to the power 4 over 2. Then we can just use the index laws to simplify this one. So sorry, before that we can change, we can make into two different terms, right? So let's just say it's 4x cubed over x to the power 4 over 2 plus x to the power 5 over 2 over x to the power 1 over 2. Then we can just simplify, so because this one is about dividing, right? Division, so you can say it's 4 times x cubed minus 1 over 2 plus x to the power 5 over 2 minus 1 over 2, and then you can simplify to x for x 5 over 2 plus x squared, right? Then you can yeah, this must be the answer, right? So a equals 2 over 5 over 2 and b equals 2. Right, so this is the end of chapter 1, and hope you understand all the concepts. And if you have any questions, you can just comment on the video, or comment below, or you can just send me the private message. If you like this video, please press like, and also subscribe this channel. Yeah, right, then let's try chapter 2 for the next lesson, which is yeah, about quadratics, and this one is quite important. So yeah, right, thank you for watching my video, and see you next time.